Very good, thank you. So LID is, he said, low impact development is what we're talking about, and I'm focusing specifically, as you can see in the title, on bioretention and permeable pavement. But before that, I want to mention something about LID and green infrastructure. We're like mixing these two terms together. There is a difference. Do you guys have an idea of there's a difference between low impact development and green infrastructure? The idea is LID is actually a thought. It's a concept. I want to have low impact development. There's nothing. A structure cannot be low impact development by itself. So everything should be approached with LID in mind, and then what you install to achieve LID is what is green infrastructure. So for example, planting a tree that has interception, that's going to capture rainfall, and some of it will evaporate, some of it will drip later with time. That is LID. Planting a tree is actually putting green infrastructure. Yes, a tree is an infrastructure. But there's a lot of things that go into thinking about LID. So for example, in this picture here, I live in Richardson, and apparently people like to speed in residential streets over there. So what we've seen lately is bumps coming up, growing from the ground everywhere. The city is putting them to slow down. But there is a way to do this with LID. If we use a street narrowing construction like here, then we're actually increasing the green space instead of putting just the bump. We're slowing down people because we narrowed the street, but also we could put a rain garden in those, or a bioretention. So that's a 3-level LID here, instead of putting plastic or a rubber non-recyclable bump on your ground. But LID can be everywhere. These are all pictures of examples of green infrastructure in rights of ways. This is a rain garden, maybe a rain garden, a bioretention, bioswale. You can see that it has space to retain some water, but also it's not heavily planted, so it's a combination of a bioswale, bioretention. This is a bioretention or a rain garden built on a corner of a street. Instead of putting a larger concrete area, you can use this for absorbing runoff. This is a highway or a large street median that is designed to capture runoff from the street and then direct it toward a drain by making it flow slowly over the rocks. Of course, bioretentions are natural in parking lots. You can put them in the islands of parking lots and allow all that runoff from the newly converted to impervious area zone, send it directly to a green area, so you get shade, but you also get stormwater capture. And this is the right of way of a home. This is my dream. I think every house in the world should have a rain garden in their right of way, that small green space that is annoying to mow next to your house. Now you put a rain garden, you don't need to mow it, you capture all the runoff in the street, and if you have, every street has one, it will capture all of the runoff from most of the watershed, and then when your neighbor upstream irrigates like crazy, you'll capture also his runoff from his irrigation. This is another idea of how you had a slopey system right here, and instead of having a high slope that's retained by a retaining wall and then runoff would go, what they did is they made it into a terraced area. They planted it, they put green stuff, so increased the perviousness. This is LID right there. Then they sloped the road itself toward this way, so it collects some of the runoff that comes from here, which is less than what would have fallen if they had made this a sidewalk, and then it runs off and it's captured in rain gardens on this side of the road. Again, dead spaces in design can be made into rain gardens and designed such that they can capture runoff. Pervious pavement can be installed in locations where for parking lot, they're very good in the system. This is the Chicago Alley project. It's a very famous, very high-cost project. Chicago is a combined sewer system city, and they had serious problems with their runoff and stormwater and wastewater, and so they were, I think, required by EPA to take action. And so what they did is they went and converted a huge percentage of their back alley behind the houses into pervious pavement. And you can see here, it absorbed a lot of water in the back alley where you drive only to go to park or your garbage truck goes. So eventually, this is what I was trying to say with the concept of LID, a complete street by itself, and I missed the first lecture, so I'm going to assume that they talked about all this stuff. But a complete street, by definition, is what LID is all about. You increase the trees, you increase your interception by the trees, you put these systems that narrow the road instead of putting bumps, you increase your pervious area, you increase your green area, you put rain gardens in these additional areas, your parking areas are permeable pavement, and the whole mix falls into the concept of LID. And bioretention and the permeable pavement, these are the green infrastructure in this picture. This is just to start with bioretention. I'm here to talk about maintenance, so I'm not going to go into any of the details of designs and operation of bioretention. We're going to talk about their maintenance. This is the first ever rain garden or bioretention built with that name as a concept. A lot of people converted impervious areas, pervious area in the past 3,000 years. But this is the first time they built it with stormwater specifically in intention, as an intention, and they played with the media and designed it with curb cuts so it absorbs water. So it's Prince George's County. It was built in the early 90s. It's still supposedly operational till now and is doing very well. Larry Kaufman is the one who designed it. He worked with that county, and now he's a famous motivational speaker because he did something like this. So that's what I aim to be eventually. So bioretention is low maintenance. This is I think that's why I was invited here, because every time I tell people you should put bioretention, you put permeable pavement, they say, well, there's maintenance. What kind of maintenance do you have? And so we're going to talk about this. Bioretention is low maintenance, but it's not no maintenance. Like anything you ever do anywhere, unless it's an untouched area, a forest that no one has ever been able to get to in the Amazon somewhere, it will need some maintenance. And bioretention is one of those that is nearly no maintenance, but it's not no maintenance, it's low maintenance. And so what's the most common cause of failure of bioretention? It's actually sediments. It's not designed as sediment basin. It's designed to actually run and allow flow of runoff to go through it and to treat typical stormwater with chemicals in it with some load of sediments, but not an abnormal load of sediments. If you design it with in an area that produces a lot of sediments, you will have probably failure. But a lot of the maintenance relates to actually reducing sediment flow into your rain garden or bioretention. This is an interchangeable term. The first thing that you need to think when you're designing a rain garden or a bioretention is that the flow going into it needs to be slow and distributed. It can't be focused and flowing very fast like those pipes that go into our streams. Otherwise, you will have problems like this, where you start because you didn't design your system to distribute the water. Water naturally will start concentrating in one location, create a channel, it will create a bypass inside your bioretention, and you will lose all the treatment that you paid a lot of money to obtain when you constructed your bioretention. In some cases, water doesn't necessarily show as a runoff there. As you can see some mark of runoff, but then you will start having failure even at the bottom in the systems. And usually rain garden bioretention have looser type of soils. They're designed like that to retain more water. And so you have a higher chance of channelization inside if you don't find a way to reduce this concentration of flow coming from your watershed into your bioretention. So one way to do this is to actually you yourself control where that inflow can go in. And so by not having it open all around, have curb cuts every few feet, 10, 15 feet, then you're actually distributing the flow in one way. You're reducing the watershed size going into your bioretention in these several curb cuts, and then you can actually apply a treatment at that curb cut. It could be included in the design to actually slow down the flow additionally right where the water comes in. If you don't have that option, you can use some type of material that will actually slow down that water and distribute it as it goes into the rain garden. Here they're using some kind of small rock riprap. You're not having a stream here that's going to take these rocks, so you don't need those big rocks, but small rocks used like riprap all over the edge. They work as spreaders. Water goes into them, flows in the spores between the riprap, and then crosses into the rain garden, slowing the flow and distributing it. You can use gravel verges, and this is gravel that is at the level with the parking lot that you construct at the system. And a treatment train, you can have a double treatment. After that, you can put a vegetative filter strip that forces the water to slow down more. So here you're doing 2 treatments before the water reaches in your rain garden. This rain garden here is not really a rain garden. There's no plants yet, but the concept still is valid. And then finally, an easy design that we're all familiar with as engineers is you can put a forebay ahead of your bioretention. The forebay will slow down the flow, capture some of the sediments, and allow the water to flow into the rain garden. So this is, let me show you this. This is here, the forebay. It's all rocks. This is in action, so you can't see it very well, but it's usually all rocks. And then this is where the rain garden is. So it goes in here and then flows from the forebay into your rain garden in this system. A second common problem in bioretention areas is the clogging of the fill material. The rain garden start clogging and water does not infiltrate in the system. And that, why would it happen? Either your watershed itself has high sediments, there's a construction project that's not well designed, there's some kind of failure that created many sediments to come into your way, a berm that broke in the catchment. Also, it could be a problem with the media mix that you used in your garden. You had too many small pores in your rain garden, and so it clogged very easily. Asphalt, if your watershed has a lot of asphalt, it naturally produces sediments as runoff flows over it. And so the media issue is basically you need to make sure that you have large pores in your system. So the majority of your media has to be sand or organic matter. You should avoid using large percentages of clay or silt. Sand or organic matter. Organic matter should not be of animal source, so it doesn't release pollutant into the system. When you use this as a mix, your pore spaces will be large enough such that clay will not get stuck in those pore spaces and starts clogging them. It just will settle down and go all the way to the bottom. The infiltration rate in your media, in the media itself, not after the rain garden is full, that's right, during the rainfall, should be such that it can allow infiltration of a 1 inch per hour rainfall event. So if your watershed is 10 times the size of your rain garden, that means you should have at least a 10 inch per hour infiltration rate. If it's bigger than that, then it has to be bigger. But usually 10% is a good percentage to think about. It's been found, actually, there's all kinds of papers that show that this is the #1 cause of failure of bioretention system, and they clog in the top 5 to 20 centimeter. So this is where they go in and they sit somewhere in that top 20 centimeter, and then they fill back up from there. And so you have all, bioretention areas are on average 4 feet deep. So you have somewhere between 3 and 3.5 feet deep of material that you paid a lot of money to build that are inefficient at all, where water is just running off the top of your rain garden. But that has a benefit also, is that you know that this is the zone you're going to have to clean once you have a clogged bioretention area. So this is only caught by maintenance if it's happening. So the way to do it is to schedule visits to your site within 24 hours of a 1 inch rainfall event. So we get here somewhere between 10 and 11 every year that are on average on a good normal year. 1-inch event or larger. And so after one of those events, twice a year, you should go there, check if that water is sitting there 24 hours or is actually infiltrating. It should not be there after 24 hours, definitely. It should have been completely disappeared, because that ponding zone in your bioretention area usually is somewhere between half a foot and a foot. And so it should not, there shouldn't be a foot of water sitting there for 24 hours with an infiltration rate of 5 to 10 inches per hour. If it is clogged, then as we said, the solution is to excavate those top 5 to 20 centimeter. You can see a clogged system. It's going to look different than your media that you put there. If you have a rain garden you visit often, you'll be familiar with the type of media. If you used a high percentage of organic matter, it will look a little bit like compost. If you used sand as your majority of your media, it's going to be sandy and clearly recognizable. The clogged system will be in clumps. It will be hard it will have several colors, might have some redness in it, and so you would recognize that, and you can check, you can bore and find out to what depth is your clogging, and then you can decide how much you need to remove. Usually it's the top 5 to 20 centimeter. If you were in a bad area, you had like a sediment spill, then it could be even deeper than that. And these 5 to 20 centimeter over rain gardens now can be somewhere between 2,000, 3,000 feet surface area. They can be very costly, especially that you're going to replace it with some material that you have to import from somewhere else. So these days we have expanded shale mixed with rain garden media. We have clean sand. We have compost, and so replacing that could be expensive. In addition, there's mulch that you put there that you're going to have to remove and replace. The plants will have to be moved out and planted again. Some might not survive that transplanting system. So it is an expensive system, and it's better to think about that during design to reduce this. Trash is a problem. It's actually what people will call you for. Look, your bioretention is not working, it's full of trash. Actually, trash has a little effect on the rain garden. It's actually those chemicals and those sediments that no one sees that will ruin it. But it is something that does not look good, and it's unsightly. People will call you thinking that it's not working. It's completely polluted. That's what pollution is in a lot of the public's mind, is if there's garbage in it. So it's a good idea to remove it, especially if it's in a high visibility area. But it is a problem too, because one, it's a safe harbor for mosquitoes. It sometimes also keeps traps water and dirty water in some small pockets that increases mosquito habitat. It could clog the drawdown or the outflow structure, and it takes volume in the forebay, which is intended to actually capture a lot of sediment, so you don't have to clean the forebay except once every 4 or 5 years. And so by having trash there, it would reduce that lifetime of the forebay. The fourth thing you need to think about is the overflow structure. And so overflow structures it's the system that's going to take the extra water straight to your drain. So if it's clogged, you are running a risk of overflowing, flooding from your rain garden into your parking lot. It's going to happen probably the day before a freeze, and somebody's going to have an accident, and that's it. So it's a life or death matter to clean your overflow structure. Some structures will clog more just because of the size of the drain or the way they're constructed. But there are firms that they do what they do for a living. So if there's not enough people that can do this on your staff, you can always outsource this or contract it. Here's a clogged outlet. That's what you see. And it might look funny that you can remove it with your foot, but if you leave it there, this mulch is going to decompose, it's going to become more small, and it can clog the outlet and can cause problems in the whole pipe system. The under drain, so we know rain gardens, they have a perforated pipe at the bottom that is intended to take some of the water after rain events, so that if there's consecutive rainfall events, it's not completely full and all that the next rainfall event goes completely to the overflow. So you put a drain at the bottom and it drains the first rainfall event slowly, such that when the next rainfall event comes, you have space to capture at least some of that drain event. And so the question is, so we put drains in all of them, in all of these systems. Do they need maintenance? Probably they do sometimes, but it's rare. There hasn't been a lot of reported clogged drains as the problem why bioretention is not working. Now, there has been reports before that were a problem in this area, and after investigation, we used to put filter fabrics, either buy those sleeves of filter fabric that fit the drainage pipe, or put a full filter fabric under the media that separated the bottom gravel from the media. And so apparently those filter fabrics were the ones that clogged very fast. And so new design, new recommendation came out actually in the newer LID manuals. Some states and counties will not certify your structure as LID if it has any filter fabric in it. Example, Harris County. Harris County put that as a line. If you put filter fabric in your bioretention, it will not get any credit. I've built, before they came up with this design, I've built like 12 rain gardens with filter fabric, and they're still working well in here, but they weren't in high traffic areas. They collected off roofs or small garden areas. So, but the new design that came is actually you put 2 inches of number 8 stone. So these are very small stones on the top, on top of larger number 57 stone that surround the full pipe. And that grading of the size of rocks from the top to bottom is enough to reduce any potential clogging for your under drain. Now, in case you do get clogging in your drain, it's a good idea in your design originally to create a clean out, and that is a pipe that would go at an angle, 45-degree angle from your pipe all the way to the top, so that you can put a hose in there and flush out anything that could have clogged your pipe in the system. The clean out should be closed. If you leave it open, it will clog the pipe itself in the system. So the plant selection is the number 6 thing you need to think about when you're doing a bioretention area. So there are lists of plants. So plants in that can survive in bioretention areas, especially if they're not in your house, if they're in right-of-ways with very little time for maintenance. You need to select plants that need very little maintenance, and that means plants that do not need irrigation, except if it's an extreme drought condition, and plants that can survive at least 72 hours with 100% soil moisture, with a completely waterlogged system. So it's easy, right? Survive 4 weeks of drought and survive 3 days of complete wetness. In reality, in areas like this, like Texas, where the DFW area, where we have a lot of clay, in those potholes, this is what plants developed, right? So whenever it rained, water gathered in those depressions, and it drained very slowly in that very slow draining clay. And then the summers were probably as hot as they are today, and these plants still survived. So the selection of actually natives in your areas that were probably in ecosystems that are very similar to what you are subjecting your plants in a bioretention is your best bet. Every area have lists developed for what best plants to use in bioretention. We've actually developed a list. You can find that we have a publication through AgriLife extension that's called Stormwater Management Rain Gardens, and in it there's 3 pages of good rain garden plants that you can use, and mostly there's a lot of invasives which are weeds, that actually would do what I said they should do, survive droughts and survive wet weather. That's by definition why they're weeds. They survive conditions that typical plants do not survive. And so these invasives, you need to avoid them. If you don't know, there's actually a website called texasinvasives.org, I think, that would list what plants are invasives and what are not. And if still in doubt, that's what horticulturists and extension agents are for. You can give them a call and they'll check it for you. The density, you don't want a forest, you want something that you can maintain. You can go in, check in the outflow structure, check different plants. So it's a good idea to keep it open a little bit. It helps also in going and weeding and removing those invasives that we were talking about earlier. If you see a plant dying and you can recognize it's dying because the rain garden, it rained for 4 days in a row, and the rain garden had standing water for 4 days, and these plants start dying, then you recognize that these specific plants will not survive in that specific condition of your bioretention, and you probably should remove them and look at a plant that is either from the others that survived and replace them with it. If it's just random with no clear environmental trigger, it's probably a disease. Again, a good idea to remove it. Diseases and plants that are getting sick, dying in some way, are usually, if you have a diverse plant system and you have a couple that die from a disease, first, most of these diseases don't transfer between various classes of plants, so it's not a big deal if they die. You can just come back and replace them with other plants that would not get that specific disease. Maintenance, if you see obligate wetland plants growing in your rain garden, for example cattail, there's something wrong. It's clogged. It is way wetter than you ever want it to be. There should never be obligate wetland plants in your rain garden. They should all be facultative. They should be able to survive that 4 weeks of drought. If you do find cattail, first look at the reason of clogging. Why is it not draining? And then second, get rid of the cattail. Yes, Roundup. It is not recommended a lot everywhere in locations where you're using something to treat runoff and remove pollution, and then you're spraying a pesticide in it. But in this case, if you don't kill the cattail, which is very hard to kill, you're actually creating a mosquito pond instead. And so this is a drastic treatment. It kills, disappears in the environment, and then you can plant again within a couple of weeks. Irrigation, again, when you plant them, even though they're these wonderful native plants, when you plant something, you should probably water it for at least a month. Here it says first few months. I actually do 1 month and stop, but I do every day in 1 month. Here and I'm using here what's recommended in general is to irrigate it 2 to 3 days a week for the first few months. My systems, again, in Dallas here survive with daily irrigation for 1 month, and then we cut it completely and allowed it to survive in nature, and we've rarely had any plant die from water starvation specifically. Then once they're established, they will survive by themselves because of what you selected, right? Now, in some cases, 2011, for example, you get droughts that have not been seen since your great-great-grandfather was here, and you have to water. They're going to die. There's some of them are going to die. We actually had a rain garden, a bioretention that was abandoned in spring 2011. We were not going to use it anymore, and we were going to build another rain garden, and so we left it by itself. And after we had 100 days of 100-degree weather with maybe 0.2 inches of rainfall during that summer, we had probably 2/3 of the plants died, but there was 1/3 that completely survived, and it only died by being removed completely and sprayed with Roundup, by the way. But droughts again. So you will need to water in droughts. I actually water usually at least once in August or late July in here. So I always have a soaker hose in my rain gardens, and I use it once when I have a rule that if it hasn't rained at all in 4 weeks and temperature or evapotranspiration has been in the 0.2 to 0.3 inches every day, I water at that point. So every 4 weeks without rainfall with high evapotranspiration, I water. It usually comes out to every other year to 1 or 2 irrigations. Again, so these are water treatment systems. They trick you by calling them rain gardens, but they're not gardens. They're not specifically made for the plants to survive. They're made to actually have good root systems, create a good biological microbial system in the soil that will improve treatment. And so you don't want to have lush vegetation, and you should probably once or twice a year cut down. If you have large trees, you have to you don't mow them, but you can just reduce the vegetation mass in the system. Always mulch your rain garden. It reduces evapotranspiration right there, and it adds organic matter. There's actually a study that showed that 100% of heavy metals that go into rain garden gets completely immobilized in the first top inch of soil, which is actually the decomposing mulch. Because heavy metals, the way they're treated in bioretention areas is immobilization with organic matter. They just form an organic matter bond, and it immobilizes there. So they found that mulch is what treats heavy metals in a system. So it not only it has the typical horticultural use, it actually has a treatment use also, and it looks good. Just information you can use. You should use double or triple shredded hardwood. You should renew it every once in a while. Just treat it like your flower bed. Same thing. If it starts decomposing, it looks bad, you can add more mulch. Watch out not to clog systems with your mulch like we saw in the other picture. And so finally, this is just to come back. This is a maintenance task schedule for your bioretention. And so you need to prune. That was the word I was looking for when I was looking at that slide. Pruning. There, pruning. And so you should prune once or twice a year. Mow the edges probably, not the vegetation itself, 2 to 12 times a year, depending on how they grow and how much grasses you have. You can remove mulch or just add on top of it if you don't have a high polluted water system every 2 to 3 years. Water, it says here 2 to 3 days for the first few months, and seldom after establishment. We talked about this. Fertilization, only if you're seeing a weakness in the plant, then you might want to consider fertilizing. And in general, the runoff is enough fertilization in your system right there. But if you do notice that your plants do not seem healthy, there's yellowing, then it doesn't hurt to fertilize. Just think about fertilizing at a time that you're not going to get a lot of rainfall during that period. Now, in my soil media, unlike the common one you'll see is 90% sand, 5 to 6% organic matter, and then some other stuff if you need it. And so that probably will require fertilization. I've actually been testing systems where the media is made of 50% plant source compost, and then the remaining is sand and maybe expanded shale, some silt, sometime I put back to reduce cost. If you have a large percentage of organic matter in your media, then you probably will never need to fertilize. It's just going to work for you very well that way. It will probably decompose and might need application of compost, maybe an inch of compost every year to replace the decomposed compost, but it will not need fertilization. Removing dead plants, you can check for that once per year. And there's other stuff like trash collection, weeding, removing mulch from overflow. You can do that monthly. Permeable pavement design, and that's shorter than the other one. Mainly, I'm putting here the steps that you would need to do in your design, because good design of permeable pavement will usually reduce your maintenance a lot. And so the most important part would be the siting and feasibility. This is what you need to think about. You know, you can look at those later, but the siting is really because these are not made to treat wastewater. These are made to treat very low contaminant stormwater that runs off from parking lot into them. And so if there are chances that these systems will have a high pollutant load, you should avoid using permeable pavement. And these include, areas with high water table, if there's high slope leading into your area, so that's going to carry a lot of sediments. Stormwater hotspots, we'll talk about that in a second. There's redevelopment site, there's a lot of construction. You should probably avoid putting permeable pavement in this area. Hotspots can be, vehicle maintenance areas, trucking centers, heavy industries, airport maintenance area, railroads, solid waste facilities. And if there's anything close like this in your watershed, you should probably think about other low impact development practices. Again, structural calculations are important for your system, just to make sure that you can hold the weight well enough and allow for infiltration of water. If there's a messing, if it starts cracking or breaking, you're going to lose the design capability of your permeable pavement. Again, what does it hold? And this is, again, is you can design it to hold different type of rainfall events. But by your permeable pavement, they capture the water that falls on them and maybe half of the driveway in between. So you're not talking like rain gardens. So it's just that area that they're treating. And you can design them to hold a specific storm depending on your weather pattern. It could be a moderate average return interval, so storm for 2 to 10 years, or even bigger ones like an infrequent average return interval storm, like a 25 to 50 years. Now here, when we design permeable pavement, we have to account for the plasticity of the soil. And there's a minimum depth of gravel that you have to put under your pervious material so that it doesn't move with the clay and crack and doesn't work. And usually, in most cases when we've designed it, it came to the 25-year storm. So just to prevent the effect of plasticity on your permeable pavement, you design for the 25-year storm minimum. So it's probably impossible to build a permeable pavement in clay zones, high plasticity, movable, expandable clay for small storms. So it makes this easier for you. You don't have to worry too much about what you're trying to design for. But how do they stop working? They clog. If these are material that is made to be porous to allow water to infiltrate through it. If you allow it to clog by small sediment particles, which are your target pollutant anyway, because that's the most type of pollutant you're going to get from your parking lot. If those sediments clog the material, it's going to be very similar to an impervious system, but now you have to explain why it's a little bit uglier. Usually it's easy because it's like permeable and environmentally friendly. But if it's not working, then you're in trouble. So what to do to prevent this from happening? Cleaning. That's what you need to do. So you need to make sure that on a regular basis, the catchment area, the area where the runoff is going to be going into that permeable material, is cleaned and swept regularly. Regular blowing, organic material, again, leaves that look big and are not going to clog the permeable material. If you leave them there and they get wet, they decompose, they become very small, and they completely clog your permeable pavement. So regular blowing of organic material, of fallen mulch, all that stuff helps. There's sweeper vacuum trucks that should be used maybe once or twice a year. These not only sweep, they also vacuum like a Hoover, but at the street level with big trucks. There's actually a company called Timco in Waco that this is not a product placement. They never paid me any money, but I happen to be there and visit their site. Here you go. They construct these trucks. You know, if you want a local supplier, that sweep and vacuum at the same time. They have different types. They have mechanical sweepers. You can use small hand pushed ones, or actually, you know, they're propulsed but driven. Weed control is something to think about in pervious pavement. Yes, weed grows through these cracks, and it's very annoying. And it's hard to remove sometimes because it's growing in a crack and it's all wedged there. You should really, the best thing to do is go and try to remove it by hand as soon as you see it. But these weeds are tricky. They grow over a weekend. You go home on Friday and there's nothing. You come on Monday and there's a whole, 2-foot high weed all over your permeable pavement. And in these cases, you need to look at ways beyond, unless you have the manpower to sit and remove all that stuff. You could, if you want to, spray them with herbicide. If you don't want to spray herbicides, you could flame them. There's flame weed killers, but these won't work with everything. So for example, we have plastic grid that we fill with gravels. This is a type of permeable pavement. You will totally burn it with a flame weed killers. Actually, even concrete sometimes can ignite, but it won't ignite if you're just burning the weeds in between. But if you sit there and you're talking to your friend, then something can happen. So just keep in mind. Grass pavers, and again, we have these systems installed at the research center I work on. It's in Coit and George Bush. So if you're interested in looking at these materials, send me an email and we can go visit. We have a grass paver, so there are certain pavers that allow for grass growth in them. They're usually overflow parking types, not something you want to park on every day because that grass needs some sun to grow. But once you put grass in your area, you have to treat it like grass also. So you have to weed it, you have to fertilize it in this case, especially that you have 10 inches of large gravel underneath it. So it's going to lose a lot of nutrients. It has to be fertilized. It has to be treated like a regular lawn in order for it to stay looking good and work as intended. Again, that's a maintenance schedule that you can look for permeable pavement. Inspect log for clogging once or twice a year, or maybe even 4 times depending on what's coming into your stormwater. Sweeping and vacuuming based on your inspection result. If you notice that you have a lot of accumulation of sediment and dust and decomposing material, you probably should do it more often. If you have clogging and problems and you do use vacuuming and you feel like you need to replace the gravel, you should vacuum first so it takes as much as the material and then you can replace that gravel. Usually, if you're in a typical use area, you won't need to do this for 20 years, probably on average. That's the average time permeable pavement will stay active as designed. After that, it's going to be hard without replacing all the gravel. If there's oil and grease, it's usually on the top. It's not a problem for the stormwater that there is oil and grease on it, but it might be needed by the client. Avoiding landscape debris, spraying weed or herbicides, and stabilizing lands across in case you have an area that looks like it's going to start eroding into your permeable pavement. This is my daughter, actually. When she was 3 years old, she's 5 now, and she was putting mulch on a bioretention area as her first job. We paid her 60 cents an hour now. Good. Any questions?